This section is on solving polynomial and rational inequalities. The first thing you need to do is have 0 on one side, as we do here, and factor. And so when I factor, what I would see is x times x plus 2 times x minus 2 is greater than or equal to 0. Now what I'll do is put a number line. Once I've factored, I draw a number line, and I put each of the zeros on the number line. So -2, 0, and 2. Because this is a greater than or equal to, the equal implies that these are going to be closed circles. And now I've got to test points in each interval. So to the left of -2, I'll test, say, -1 billion. So negative times negative times negative is all negative, which is not greater than or equal to 0, so I will not shade. Then I'll test -1, so that'll be negative, positive, negative. So that is positive when you multiply it, so that works. Then I can test 1, so positive, positive, negative, which is not greater than or equal to 0. So I don't shade there. And finally I test to the right of 2 like 100, positive, 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 which works. So that's how it looks graphically. You can write this as -2 to 0. These are brackets because you're including the endpoints, and then union, bracket, and infinity is not a number, so that's always a parentheses. You can also write it -2 less than or equal to x, less than or equal to 0, and then maybe a comma, x greater than or equal to 2, like this. So that's a basic polynomial inequality. Something to know is that these were all single roots, and so that means you're going to change sign every time, so you're always going to switch. So if there were even roots, you would bounce off. It would not change sign. So in this case, this is already factored. I have roots at 0, I've got -2, and I've got +4. And so to the left of -2, like -100, if you plug in -100 here, negative cubed is negative, then you'll have negative plus 2 is negative, negative minus 4 is negative, b squared, it's positive. So I've got negative, negative, positive, which is positive, so that does not work. So I'm not going to shade here. -2 is a to the first power, so I'm going to change sign, so that means I would shade here. 0 is odd, so I'm going to change sign there. It's an odd root. I'm going to change sign there, so I'm not going to shade here. And then 4 is even, so if I didn't shade here, I'm not going to shade here either. So that's a shortcut, though you can always test points individually. There's a shortcut, and so we have two parts. We have the -2 to 0 part, and we also have the single number 4. So that works as well, and here's another way to write that. So -2, 0 in brackets, and then also 4. So those are polynomial inequalities. Here's a rational inequality. It's pretty similar, but slight difference. We still have to have 0 on one side and factor. So I factor. I still put each of the zeros and the denominator on here, but notice that the greater than or equal to is going to mean the numerator ones are closed circles, but the denominator one is still open circle, regardless of whether this has an equal to or not. You can never divide by 0, and so this must be an open circle. I can do the same thing with switching signs or not switching signs, depending on whether it's a 1 exponent or a 2 or any odd or even number. But let's go through it again. If I take a number to the left of -4, like -100, negative, negative, negative is negative. That doesn't work. If I take a number between these two, like -3.5, that would be negative, negative, and positive, which is positive, so that works. If I pick 0, I'll have positive, negative, positive, which is negative, so that doesn't work. And finally, 100 is going to be positive, positive, positive. So there's my graph, and then here would be my solution. Okay, a couple more examples. We have another rational inequality. I factor the numerator. Denominator is as it is. So I know at -3 and at 2 I'll have closed circles, and at 0 I'll have an open circle because it's in the denominator. So here's my individual points. To the left of -3, like -100, I have negative, 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 which is negative, so that doesn't work. And then because these are each single roots, I'm just going to switch off. So no shade, shade, no shade, and shade. And so I have -3 to 0, where I don't include the 0, but I do include the -3. And then I've got 2 up to infinity. Now, one other way you might have to do a problem like this is in this example. If we wanted to find the domain of the function f of x is equal to the 4th root of x squared plus 3x, you can't take an even root of anything negative, so therefore the domain is going to involve looking for places where x squared plus 3x is greater than or equal to 0. So now we have a polynomial inequality. You factor it, You put -3 on your number line and 0, close circles because it's greater than or equal to, check individual intervals, and you get your answer either here in green or here in blue for the domain of this function.